At the heart of every network lies protocols. Protocols are simply rules of conduct and communication. The governing protocol of the Internet is the TCP/IP protocol suite, Transmission Control Protocol, Internet Protocol Suite. Most common protocol suite used on the Internet today. The most common network protocols that you will need to understand and be familiar with are IP. This is the protocol that functions primarily at the OSI layer 3. TCP, which operates at layer 4, establishes connections and reliability of data transport between devices. Together, they make up the TCP/IP suite. It uses 4-layer architecture, the network interface, internet, transport, and application. There are two different models that you need to understand. The OSI model, which has layers 1 through 7, and the TCP/IP model. The OSI model is most commonly used for troubleshooting. The TCP/IP model, it correlates somewhat, and I'll break it down for you a little later, into the layers of the OSI model. The next protocol to understand is ICMP, or Internet Control Message Protocol. You may know it as ping. It's one of the core protocols of TCP/IP. It's used by devices to communicate updates or error information to other devices, primarily used to query and relay those messages. The ICMP message field is broken up into types, codes, and then a checksum, an 8-bit type, an 8-bit code, and then a 16-bit checksum. The checksum is there to verify the message integrity, that it has not been disturbed in transmission. The different codes that you can receive using ICMP are 0, network unreachable, through 12, host unreachable for type of service. It's less important for you to know individually each one of these types of codes. Just be familiar with the concept of the ICMP codes. Some of the more common attacks that use ICMP are network discovery, you might know them as ping sweeps, or the ping of death, which is simply a malformed ICMP packet that once received by the targeted computer will bring the computer interface down, basically creating a denial of service condition. Next is the Simple Network Management Protocol, or SNMP. First introduced in 1988, supported by most network equipment manufacturers. Each SNMP managed device has an agent or a service that listens for and executes SNMP commands. The agents themselves are password protected, and there are 3 different variations that you'll need to understand. SNMP versions 1 and 2, not necessarily used as much today, but they are still out there. Today, because of the vulnerabilities associated with versions 1 and 2, you should see SNMP version 3, introduced in 1988. It uses usernames and passwords along with encryption to address the vulnerabilities. Next is DNS, or Domain Name Service. It's simply a database with a name for each site and the corresponding IP address, mainly because humans do not understand and remember strings of numbers very well. So it's a helper, if you will, so you don't have to enter www.microsoft.com. So you don't have to enter the IP address for www.microsoft.com. DNS will do that for you. DNS is a wide focus of attack these days. Attacks such as DNS poisoning and zone transfers. DNS poisoning substitutes fraudulent IP addresses for the actual IP address that your user might be trying to reach, whereas a zone transfer allows the attacker to access the network hardware and operating system information. The TCP/IP protocols used for transferring files are FTP and SCP, File Transfer Protocol and Secure Transfer Protocol. The methods for using the FTP on a local host, for instance, is by a command prompt or an FTP client. Using FTP behind a firewall can present some unique challenges. You'll need to set, for instance, your FTP client into FTP active mode or FTP passive mode, depending on whether or not it's sending, receiving, or both. Some of the vulnerabilities most associated with FTP is it's a clear text protocol. That means it does not use encryption to send files back and forth. Those files using FTP are vulnerable to man-in-the-middle attacks. Rather than using FTP, the simple unencrypted plain text form, it's encouraged to use secure transmission options like SFTP. This allows you to send the same file using basically the same protocol through a more secure encrypted channel. SCP, or Secure Copy Protocol, is an enhanced version of Remote Copy Protocol. This, however, encrypts the files and commands. It's usually found mainly on Linux and Unix platforms. However, there are special programs that can be employed in a Windows-centric environment. Next, let's talk about IP version 4 and IP version 6. The current protocol standard of the internet is IP version 4, although it is actively being phased out. Originally introduced in 1981, the number of available IP addresses is limited to 4.3 billion. Well, that sounds like a lot until you recognize that we are currently out of available public IPv4 space. That's why IPv6 had to be created. It's the next generation of the IP protocol that attacks the weaknesses of IPv4. It's a more secure and better standard by far. However, it is a lot more complicated. Here's a look at the differences in the headers between an IPv4 and an IPv6 packet. IPv6 provides enhanced security features like cryptographic protocols. Its new authentication header prevents IP packets from being altered in transmission. It is inherent where IPsec is inherent in IPv6, whereas IPsec has to be invoked or engaged with IPv4. So security is baked into IPv6, where it's absent in the IPv4 protocol. Here's a simple compare and contrast between the fields of IPv4 and IPv6. To successfully navigate the Security Plus examination, you should be familiar with these different fields and the explanation of what each field does.